Hi everyone, Francis is here. In today's video, we'll be looking at the subject partial fraction decomposition. Before I move on, what are the prerequisites to this subject? Before you can, what are the prerequisites to this subject, or what you need to know before taking this topic? It's long division of polynomial, factorizations or factorizing higher order polynomials polynomials that are more than whose x power is more than 2, and then your indices. That's it. So with this, let's look at the example we have here. The example we have here says write a partial fraction decomposition of x plus 7 over x squared minus x minus 6. For us to be able to work this or solve this problem, we need to ask ourselves, is this partial fraction, is it rational or irrational? If it is rational, and what does it mean for a partial fraction to be rational? It means that the highest power we have at the numerator is less than the highest power the highest power of x we have at the numerator will be less than the highest power we have at the function at the denominator. And as you can see, the power of x here is less than the power of x here. So the power of x here is greater than the power of x here. So this is a rational partial fraction. The next step will be to factorize this. And when we factorize x squared minus x minus 6, we'll have this expression x minus 3 and x plus 2. If you have a problem with trying to factorize, do well to check out previous videos in this series. The next step will be to write, and in this case, what we have here are two distinct linear factors. If you look at our factors here, when we factorize this, we're having two distinct linear factors. And if you look here, this is an example. The example here says we're having two distinct linear factors. So keep in mind, the case will change as you will see as we move on, if we have non-distinct linear factors. All right. So having said that, the next step will be to write our denominator as x minus 3, one of the factors. And then the goal here is to look for the constant that will be at each of the numerator here, at the numerator, such that when I add these parts, I would get what the original partial fraction I was given. So we decompose them into writing the denominator to be x minus 3, and the next denominator will be x plus 3. And then, since we're looking for, our aim here is to look for what constants will be at the numerator, such that when I add them, I will get the original factor. I would write the numerator to be an unknown. And what will be the unknown? I will represent this unknown to be a and b. What values can this a and b take? They will only take real numbers. Or you can also call them constants. Okay? So with that said, the next step will be to find a common denominator. Already we already have a common denominator here, which is x minus 3, x plus 2. Okay? Or what you can call, say, take LCM. Take lowest common multiple. So when we do that, it will be what we have as the lowest common multiple of this will be x minus 3 and x plus 2. The next thing we're going to do will be to multiply both sides of this equation or equalities, to multiply both sides by x minus 3 and x plus 2. When I do that, I would have x plus 7 on the left hand side, and when I do that on this side, I would have x into bracket x plus 2 plus b into bracket x minus 3. The next step from here will be to distribute a into this, distribute a into this, distribute a into this, and then distribute b. Okay, so we'll multiply a times x, we'll have this, multiply a times 2, we'll have this, multiply b times x, we'll have this, multiply b times minus 3, and we'll have this. So from this expression, the next step will be to to collect like terms. Okay, we'll add oranges with oranges, and then we'll add apples to apple. Okay, so we'll have x on the left hand, on the right hand side, on the left hand side here. We equate it with every x variable, every variable that has x on the right hand side. And what are the variables that have x? It is ax, bx. When we equate that, we would have this expression. Since we have x on the both sides, we can cancel out, and then we'll have 1 equals to a plus b. You can call that, for reference purpose, equation 1. The next step will be to equate, like I said, add apples to apples and oranges to oranges. Equate 7x, the constant we have on the left hand side, with what the constant we have on the right hand side. That will be 7 is equal to 2a minus 2b. 2a minus 3b, sorry, I misspoke. And we'll have this expression. You can call that, for reference purpose, equation 2. Now, with that said, what we have here, if you look at it, you recognize what we have here to be a simultaneous equation, or two linear solving two. This is a two linear system, and which we know how to solve. So we either solve whichever method you want to use, elimination or substitution method, but at the end of the day, you have b is equal to -1 and a is equal to -2. So that will be it for the end of that will be the end of the lecture. I'll see you in the next one. Bye for now.